Assalamualaikum and selamat sejahtera. I will talk about the theory of friction on the inclined plane. It is crucial to comprehend the difference between static and kinetic friction, as well as the fundamentals of friction on the inclined plane and how this force impact motion on inclined surface. The friction force that a stationary item must overcome in order to begin with moving is known as static friction. It changes inside up to a maximum value which might be found using F(S) max equal to mu8xr, where mu8 is the coefficient of static friction and r is the normal reaction force. Kinetic friction, on the other hand, acts on an objective that is already moving. Its value is generally constant and given by Fk equal to mu kr, where mu k is the coefficient of kinetic friction. And the following is the part of the weight that is acting down the slope. S equal to W sin theta. Here, theta is the angle of inclination and W is the block weight. Until the angle theta approaches the angle of friction, the item stays at rest. At this point, tan equal to mu. The block is ready to slide at this angle, which means that the maximum static friction has been achieved. Moreover, an external force P must overcome both the friction resistance that opposes the motion and the component of gravity that pulls the block downwards in order to propel the block up the plane at a constant velocity. The entire amount of force needed is P equal to W sin theta plus mu W cos theta. In engineering application, including ramp design, conveyor system force accumulation, and slope and returning wall stability assessment, and understanding of the relationship is essential.
Selamat sejahtera kepada Dr.Fazimah. I introduce you. The theoretical method to determine the friction force is W multiplied with sin delta plus mu multiplied with W cos delta. The mu is equal to the tan delta, where mu is the coefficient of the friction. The weight of the friction block is measured by the spin balance or electronic balance. We obtain the weight of the friction block is equal to 0.76 Newton. This is the experiment setup diagram. First, we place a friction block on the trigonometry table. We adjust the angle of inclination of the trigonometry table. When the friction block is start to move, the angle on the protractor is recorded. The angle of the protractor multiplied with tan is equal to the coefficient of the friction. In test 1, we obtain the angle of the inclined plane is 21 degrees. We obtain that the coefficient of the friction is 0.2 F4 based on the equation. After that, we replace the friction block with cos and add the weight hood to undergo the other test. In test 2, when the angle of the inclination of fence is 0 degree, we require 0.25 Newton of the weight hood to make the friction block to move. In test 2, the 4 steps we obtain through theoretical method is 0.292 Newton. After that, we calculate the percentage error difference of test 2. 0.292 is minus with 0.25 or 0.25 multiplied with 100%. We obtain that the percentage error is 14.38%. The experiment data result is as shown. Since the percentage error of our experimental results is lower than 20%, the experiment is success and achieved to determine the coefficient of friction block with the trigonometry table under different angle of inclined plane.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Razi bin Zolkeflee. My matrix number is CD into 40358. Okay, for the observation in this experiment, we analyze how friction behave when a wooden rock strike on an inclined plane at different angle. Let's walk through our observation. In test 1, we started by giving the block again the push to overcome static friction. It began sliding steadily and we recorded the angle at which uniform motion occurred as 21 degrees. This is also referred to as the angle of friction. In test 2, we keep the incline at 21 degrees and gradually add the brake until the block moves smoothly at constant velocity. The force required at this point was 0.25 Newton. For the test 3, we lowered the angle to 10 degrees. As expected, it took more effort to get the block moving. 0.45 Newton were needed to maintain motion. Okay, in test 4, we increased the incline to 20 degrees and the required force rose to 0.6 Newton. In test 5, with 30-degree incline, we observed a force of 0.7 Newton was needed to keep the block moving. And finally, in test 6, we increased the incline to 45 degrees. Interestingly, Even though the angle was steep, the block slipped more easily, and the required force was only 0.72 newtons, the lowest resistance observed to reduce the effect of normal force. This result illustrates the relationship between inclined angle and friction force, confirming that while greater angle reduce normal force, they increase the component of weight active down the slope, both impacting the required applied force.
Assalamualaikum warahmatullahi wabarakatuh. I'm Afif Syafi bin Mohamad Yusoff with matric number AD240112. Now let's move on to the discussion part. The first question is discuss the values of P obtained by the experiment and calculation. Compare those values with the force S acting down the plane. As the angle of inclination theta rises from approximately 0 to 45 degrees, both the calculated and experimented values of P generally increase. This is true and it makes sense because as the angle increases, a greater upward force is required to overcome the friction and the component of gravity pulling block down the plane, which is the mg sine theta in this case. If S is equals to mg sine theta, or as it is shown in the free body diagram, then it should always be less than P because S is the force acting down the plane due to it, and it does not take into account with the friction force, either static or kinetic friction. Next, the next question is B. Suggest some reasons why there are differences occur between the values of P by experiment and calculations. The first factor being friction variations. The coefficient of kinetic friction may have been slightly different or completely not constant across the surface when sliding up the plane as opposed to sliding down. It could be because of the uneven surface of the plane. And the other factors could contribute to this variation. It could be the transition from static to kinetic friction. The second factor could contribute to the variation of the differences between P experiment and calculation is the effect of the pulley and the core. Although it could contribute like this small, the variations may arise due to friction in the pulley or the mass of the cord that are not taken into account and considered by simple calculations. And the last one will be the parallax error. Parallax errors are errors in the reading of the angle from the protractor using the plumb line that can lead to inaccuracies in the cosine and sine components used in the calculations. The last question of the discussion is state the differences between friction on the horizontal plane and friction on the inclined plane. There is the difference in the amount of friction and the forces required to overcome it between and inclined planes, where the normal force is diminished by the cosine of the angle, and gravity has a component acting down the plane, and a horizontal plane where the normal force is usually equal to the weight, and gravity does not directly drive motion along the surface.
Okay, so now I'm going to conclude this experiment. Basically, to conclude this, the aim of this experiment, the friction on the inclined plane, basically was to determine the coefficient friction between the friction block with the surface part of trigonometric table. Okay, so basically, the magnetic force required to overcome the friction of block with the surface part of trigonometric table to start moving under different angle of inclined plane. So the higher the angle of the inclined plane, the greater the magnetic force required to overcome the friction of the block with the surface part of trigonometry. Okay, actually, we also have a lot of errors and failures as well. Some flaws and failures that led to lower accuracy experiment results. First, the pulley on adding the weight hook to the end of cord of friction block is not ideal. So it may have friction. The standard to determine the critical sliding point of the friction block is subjective and not consistent. The inaccurate angle measurement to reduce the static friction of the friction block due to the plumb block to indicate the angle. So basically, when adding the weight hook oscillates and distribution force is not uniform. So actually, we advise that some steps need to be done to improve the process. Okay, basically, to improve the rust surface and lower the friction force. So the new pulleys are either changed or polished. So basically, we get more accurate results basically, or get a stable result. The experiment steps are performed 3 times to get average results. So record the experiment trial by camera to standardize a critical solution. And then to increase the accuracy of experiment result, we can use the digital inclinometer to indicate the angle of inclined plane. And adjust the inclination plane. The motion sensor will be applied to determine constant velocity of friction block pressure. So the method for adding force to move the friction block, a linear force actuator can replace the weight hook. The force applied to precise point. So, thank you.